Hey guys, so I am here to talk about polar ecosystems with you today. So last quarter, third quarter, we left off talking about marine mammals and we got through all of the marine mammals except for polar bears. We never got to that. So what I want to do today is give you kind of an introduction to polar ecosystems. We're going to go over some of the different types of ice so that you understand all of that going into some of the climate change things we're going to talk about over the next couple of weeks. And then at the very end of this, I will go into just some quick details on polar bears and what their life is like and things like that. All right, so let's get started. Okay, so first of all, we have two polar regions. We have the Arctic and we have the Antarctic. So the Arctic is going to be at the top, okay, northern hemisphere, and then the Antarctic obviously is at the bottom, where Antarctica is. So the main difference between the two is that the Arctic Ocean is an actual ocean that is surrounded and enclosed by land. It's really the only ocean we have that's enclosed that way. It's surrounded by land on all sides: Russia, Canada, North America, or Alaska. And in the wintertime, the entire thing is covered in ice, but in the summertime, that ice melts back, and along the edges of the continents, there is no ice, but the ice in the middle stays there all year long. One of the big components of a food web in the Arctic Ocean is sea ice. And so sea ice is something that grows on the bottom, or I'm sorry, not sea ice, ice algae. Ice algae is something that grows along the bottom of the ice, okay? It's a green algae. And you may have seen photos before of icebergs that flip upside down, and once they flip, they're green on the bottom, and that's because of the algae that was growing on the bottom before they flipped. And so not only do you have this algae that lives attached to the bottom of the ice, but within the ice you've got all of these crevices and cracks, and you've got worms and copepods and little shrimp and all kinds of things living within that ice. And so that's kind of that second step up on the food web. And so in an ocean where you have in a lot of places for a good portion of the year, sea ice covering it, you're not going to have all of that as much free-floating algae like you would in the rest of the ocean. And so this algae instead attaches to the bottom of the ice. And you would think, how is sunlight going to get through? Because sometimes the ice is, 5-10 feet deep, or even thicker than that. But the sunlight does actually make it through that ice. And so you've got this algae living down there, creating a big base of the food web. And then the tiny little organisms that eat it are that second step on the food web. And then from there, let's see, so if we've got this plankton here, okay, which is including the ice algae that I'm talking about, Arctic cod then eat some of those zooplankton that are feeding on that algae. Okay, and so Arctic cod are very common in the Arctic. And then from there, you've got some of your smaller whales, different toothed whales like the narwhal and the beluga that will feed on those organisms. A lot of different seal species that will feed on the Arctic cod. And then, of course, you've got your polar bear there at the top. There's not a walrus here, but you've also got walruses. You've got baleen whales that are coming in and feeding on plankton, and the krill that's there sometimes as well. All right, so it's not a very diverse food web. There aren't a whole lot of things, if you were on a coral reef or something like that. But this is kind of what the food web looks like. And so if we just look at the steps individually, if you remember, we went over before this primary producer, and then primary consumer is the next step up, and then secondary consumer, and let's get me out of the way, and then tertiary consumer. And then your apex predator is your top predator on the food web. And sometimes you won't always have this tertiary consumer. Sometimes you go straight from secondary consumer to an apex predator. You've just got 4 total steps, and that's fine. Sometimes it works out that way. So here's a look at the Arctic Ocean in the winter, really the end of winter, so when it's at its thickest. And you can see the entire ocean is just completely covered in ice. Okay, from Russia all the way across to Alaska, to the top of Canada and Greenland over here, just ice covering the whole thing. Now there are some areas where ocean currents kind of break it up and ships can move through, so there are some places where it's broken, but for the most part, the entire ocean is covered in ice in the wintertime. Once you start moving into April, and especially May and June, that's going to start melting back with the warming temperatures. And so once you get towards the end of summer, this is what the Arctic Ocean is left with, so far less ice. And so this is a big change, big seasonal change. And so you have a lot of species that will move in when this ice is gone. You have a lot of species, that their seasonal patterns are tied to this ice being gone and then coming back and being gone and coming back. And so a lot of species, especially the polar bear, we'll talk about how this affects the polar bear. Another example here, these are beluga whales. And so in the summertime, or as it starts to warm, you know, the belugas, they can freely swim about the Arctic Ocean. But when winter starts approaching and you start getting this freeze over here happening, the beluga whales are going to start losing places where they can breathe. And so they've got to keep these breathing holes open for themselves. And if they don't, they're not going to have, you know, it can be miles until the next breathing hole. And they can actually use their echolocation to help find breathing holes. But it is part of their job each winter to keep this breathing hole open for themselves. And a lot of them, you can see scars on their backs. I'm going to show you a video in just a minute that shows that as well. But so this is one big sort of adaptation to living in an ocean that covers in ice, is sometimes you've got to keep that ice open. Another species that has to do this is some of the seals, and they will actually use their bodies to sort of rub against that ice over and over to keep this hole open for themselves. And so if you are a species that is you know, kind of tied to this one location, you have to continuously keep coming back to the same location to breathe, to survive. That makes you pretty predictable. And so that is where the predator of the polar bear comes in, and they will hang out by these breathing holes, and that makes it a little bit tough for the seals and the beluga whales. So let's watch a quick video here. I'm gonna watch a quick video here on the polar bear. Belugas.
Belugas are extremely thin, and most of them are horribly scarred. But their wounds were not inflicted by the ice. A whale would be a huge prize for any meat-eating hunter, and these belugas, trapped by the ice, are within reach of polar bears. Well aware of the danger, the belugas stay submerged as long as they can. But they can only hold their breath for about 20 minutes. Catching a 4-meter-long whale that weighs 1 ton is no easy task, even if that whale is weakened by starvation.
All right, and so not an easy task, and I don't know how often polar bears are actually successful at catching belugas. I don't think it's very often, but it is possible, as you can see from this photo here. So interesting. And so again, here's just a comparison of summer versus winter. So a drastic change. You know, the polar bears are really limited to hunting in the winter. I'm going to talk about this in a little bit again, but this is when they're hunting. When the ice is extending out to the continents, all around the edges, you have polar bears. In the summertime, the ice is not extended to the continents, and they don't just live, you know, out in the middle of the ocean on the ice during the summertime. They stay and they stick in the continent. They stick to the continental areas, and so they only hunt when the ice is like this. And so we'll come back to that in a little bit. Okay, so the Antarctic Ocean. So obviously very similar to the Arctic. You've got the same abiotic factors, right? It's very cold. It's very extreme. Not a whole lot of diversity, not a whole lot of different types of living things. And so a lot of similarities, but you don't have the same species. There are a few species that are similar, like there are a couple of whales that actually, you know, migrate the whole world. Like you've got killer whales and you've got blue whales and humpback whales. But aside from a few different whale species and then some different things like krill, you really have a completely different community of animals, of organisms than you do. And so there's no polar bears in the Antarctic, okay? there's no beluga whales, there's no narwhals. So instead what we have is penguins. We have a lot of penguins, and we have a whole different set of seals. And so the other big difference is that this is an ocean that's encircling a continent. So the Antarctic Ocean, or also called the Southern Ocean, is just circling and circling around the continent of Antarctica. And then it kind of merges into the Atlantic and the Pacific and the Indian Ocean. There is no real border where they really start or begin, whereas the Arctic itself is kind of enclosed as its own little area. So there is the ice algae growing in the Antarctic, but it is not a huge piece of the food web like it is in the Arctic. Instead, here you've got more of the free-floating phytoplankton, and that is promoting these huge populations of krill and these really big swarming massive blooms of krill. And we talked about this with the whales that are attracted to those areas to feed. And this also happens in the Arctic, but to a larger extent in the Antarctic Ocean. And so where you've got the interesting component of the food web being the ice algae in the Arctic, down here we've got the krill, okay? So you've got the whales that feed on the krill, you've got penguins, you've got a whole variety of seals, and a variety of penguins as well, not just one type. And so that krill is really kind of, not the bottom of the food chain, but the important piece of the food chain that kind of brings all of these species together. So we can watch this video here. The leopard seals and the
It returns to the place where it last left its chick in the hope that it might still be close by. But chicks self. Aware of the leopard seal's presence, the penguins press together at the ice edge, unwilling to be the first to risk diving in. Occasionally, the seal comes out onto the ice and attempts to grab one. But its most successful strategy by far is to lie in wait. It hides behind a corner of ice. The emperors gain confidence and make a dash for it. The first wave of penguins escape. Once in open water, they will be safe. But the seal is alerted by the noise, and through the mass of bubbles, it makes its attack. Almost invariably, it makes a kill. Encouraged by the absence of the seal, the remaining penguins make a break for the open sea. Their chicks will fledge, and when the Antarctic autumn is near its end, these adults will walk across the newly formed ice to endure yet another winter on the frozen sea.
Okay, so some similarities between the Arctic and the Antarctic. You've got different apex predators. You've got the polar bear and the leopard seal, but all of these penguin and seal species, they kind of have this, looming threat of a apex predator always there. So they're always kind of on the lookout and on the run from these top predators. Let's see what else. All right, let's keep looking here. All right, so just some of these species here. You've also got killer whales, and you can also have killer whales in the Arctic Ocean as well. So that's another species that is kind of shared between the two. Killer whales, they roam the entire planet, so they are found in both places, which is rare. One species to be found on both ends of the earth, but there are, and supposedly there are more and more killer whales working their way into the Arctic region. All right, so moving on. If you look here, this is just kind of the Antarctic Peninsula that comes up here pretty close to the southern tip of South America. And as you look through these, I think there's about 7 different varieties of penguins. There's like 5 or 6 different types of seals, 5 or 6 different types of whales. And so when you look at a food web, we kind of condense it down. It just says, penguin and leopard seal, but there are a variety of different types of seals, a variety of different types of penguins, lots of different types of whales. And so there's not a whole lot of other things living there, but there is a variety of the different types of things that are there. And again, you probably remember this. This is a blue whale migration pattern map. And so if you remember, we said that in these warmer oceans, they'll spend the winter there to mate, to give birth. And then when the sun comes out and starts warming the ocean, those big phytoplankton blooms happen, and those big, huge swarms of krill are then supported, and so the whales move in to feed on those. And again, this happens in the Arctic as well as the Antarctic, but the krill are kind of a bigger piece of the food web in the Antarctic. Okay, more penguins and some ice. We're going to go over different types of ice in just a little bit. And so again here now, if you look at the winter, okay, you can see that sea ice is really surrounding Antarctica, and in the summer, most of it melts back. So big difference, big change. All right, so one more thing I wanted to talk about was something called the Arctic Circle and the Antarctic Circle. So when you have, let's see, I have this little egg here, it's a little kid's egg, but if you have the globe around the middle, you have the 0 latitude, and 0 latitude is the equator. Okay, at the top is 90 degrees, and at the bottom is 90 degrees at each of the poles. Okay, so around 66, which is towards the top and towards the bottom, around 66 degrees latitude, you have something called the Arctic Circle that begins and the Antarctic Circle. This line begins at 66 because that is the place on the planet where everything either above that or below it towards the poles experiences at least one 24-hour period a year that has either no sunlight or all sunlight all day long. Okay, and so these phenomenons are called a midnight sun. So a midnight sun is when you have sunlight for 24 hours, okay, for the entire day. Now right at that Arctic Circle line, you'll have that at least one time throughout the year, maybe a couple of days. As you get closer and closer, you get a longer and longer period of it, and by the time you get up to the very North Pole, you actually will have almost a full 6 months of midnight sun, meaning just continuous sunlight all day long for 24 hours, day after day after day. Okay? And when you have that happening in the northern hemisphere, you have the opposite happening at the southern hemisphere. You'll have what's called a polar night, where you have all of those hours of darkness. So right at that 66 latitude south line, you'll have it for about 24 hours. But then as you move further and further towards the actual South Pole, you'll get to where you have a longer period of just complete darkness. And at the very, very South Pole, again, up to almost about 6 months of just nothing but darkness. Okay? And so that's what defines the Arctic Circle and the Antarctic is at the point on the Earth to where you get to where there is a 24-hour period of darker sun. Okay? And so always remember, and I'm going to ask you this on the quiz. I already made the quiz, so I know I asked you this a couple of times, but make sure you realize that the season that's happening in Antarctica is always going to be the opposite of the season that's happening in the Arctic. Okay? Remember, opposite seasons in the southern hemisphere. So like right now, we are coming out of winter, and so down in the southern hemisphere, they're coming out of summer right now. So make sure you always remember that. Okay, so this is where the actual and this is what I mean by the 66 degree latitude line. Okay, and so everything inside this is considered the Arctic Circle, and they experience that midnight day. Midnight sun is what that should say, and polar night. I'm going to change this. This should say midnight sun. I will fix that before I upload it for you. Okay. And this just has to do with the tilt of the Earth. So this is a review. I'm sure you've learned this at some point before. But again, the Earth does not sit straight up and down. When you look at it in the way that it rotates, it's at an angle. It's at a tilt. It's tilted. And so sometimes that tilt puts the South Pole within enough shade of the Earth itself that no sunlight is hitting it. And other times, at that same time, the North Pole will be tilted so much towards the sun that it's constantly getting sun and there is no shade for it whatsoever. Okay, so always the opposite happening, North versus South Pole. Okay, so I'm not going to play this entire video. Oh wait, this is the one I'm going to play the whole. There's another one I'm going to play just a portion of. Next week, we are going to go over climate science and climate change and exactly what that means and a whole lot of different components of exactly what types of things are changing on our planet. And a lot of those things are happening at the poles, have to do with glaciers and ice sheets and sea ice and things like that. And so I want to go over the different types of sea ice with you so that you know what the differences are. So I'm going to play this video here quickly. Okay, and then we'll go over what some of these different types of ice are.
The Arctic sheds its winter coat. Meltwater flows in vein-like streams, symbolizing the vitality of the region. Ice. Beautiful ice. Ornik, Kanik, Masak. Inuits have dozens of words for it. And in the frosty wilderness of the Arctic, it's easy to understand why. There's no end to the variety of ice here. Vast glaciers invigorate the ecosystem with chilly fresh water. Remarkable iceberg sculptures rise from the water, shaped like only nature knows how. And sprawling white carpets of pack ice extend to the horizon, beckoning intrepid exploration. Mesmerizing shades of whites, greens, and blues paint an inspirational picture in the Arctic, laid out for all to see, like Mother Nature's canvas. Each frozen formation is a different brushstroke on this multi-hued masterpiece. To witness the Arctic is to immerse oneself in the artwork.
Okay, so we are going to go over some of these different types of ice. I'm going to try and move quickly through this because I know you guys don't want this video to take 40 minutes. Okay, if you're taking notes, I didn't say this at the beginning, but I know that I explained earlier on, you have the option to take notes. I'm basically going to give you 10% for your notebook, and so if you decide that you don't want to take a notebook, that's 10 points off your final grade. You can easily get a B or a C. I mean, if you did everything else and a little bit of extra credit, you could even still get a 90. Okay, so it's kind of up to you whether or not you want to put in that time and try for an A to do the notebook. If you do the notebook, here's how you could set up this page, just, kind of like the same way in classes I would show you this and you kind of draw it out first. This is just kind of a diagram. I can move this for a second. This is just kind of a diagram here to show you what these different pieces of ice look like, and then just leave some space towards the top to write about each of them, okay? And I'm going to just go real quick over these different types of ice. I don't want to lose a lot of time. All right, so a glacier. This is almost like a river of ice, and so glaciers are found on land, not in the ocean. They're found on land, usually in very mountainous areas, and a glacier is it's compacted ice and snow year after year. So every winter you're going to have snowfall, 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 and it's going to compact and sit on top of each other, and it's going to get compacted down tight, okay? Summer is going to come along, and a top layer of that may melt off, okay? Maybe more will melt off than what compacted that previous year, or maybe less will. Just depends, okay? The next year, more is going to come and compact. And so you have this layering year after year after year after year of many, many, many layers of ice, and that forms a glacier. And a lot of times glaciers are on slopes, and so gravity is the weight of the glacier itself, because of gravity, is actually moving down the slope. And so that's why we call them rivers of ice. Okay, so these are very, very old. Glaciers are pretty permanent structures. They're not there forever, but the glaciers that we have around today are hundreds or thousands or tens of thousands, or in some cases, many tens of thousands. I don't know if we have glaciers that are hundreds of thousands of years old. We may. But they're very old. They've been there. They're not something that kind of come and go year by year. They're pretty long lasting. And so this is the edge of a glacier where the glacier has kind of moved down and it's made its way out towards some kind of a bay. And you may have heard of fjords. Fjords are big kind of valleys, not really valleys, like in Frozen. In Frozen, they live in Frozen 2. That's the fjord that they live in, where the water is rushing down at the end of the movie. But glaciers carve out fjords. So you may have heard that word before. Okay, an ice sheet. An ice sheet, we have two of these. And basically Greenland is a continent. Okay, there's rock down there somewhere. There's continental crust there somewhere down below. But there's this mile thick, at least a mile thick, of just ice. And that's that same thing as the glacier. It's just compacted ice from years and years and years, many hundreds of thousands of years compacted together. And we call that an ice sheet. Okay, the one in Antarctica is the largest one, and the Greenland one is the second largest one. And we only have those two ice sheets right now. Okay, and so Antarctica. And during our last ice age, we had ice sheets covering parts of North America, and of course Greenland was as well. But we're not in an ice age anymore. We don't have this one. But previously, we had more ice sheets on this planet than what we have today. Okay, as an ice sheet makes its way out towards the edge of a continent, it kind of flows out onto the ocean, and it's actually kind of grounded and connected along the coastline. But the rest of it, once it kind of moves out over the ocean, you have this big area it's just this big hunk of ice. It's basically floating on the ocean. It's very big, and so it doesn't necessarily rise with the tides. The tides will rise and fall, alongside it. So it's a very, very big connected piece of ice. And so it's just this big wall, basically. And so you've seen pictures of this. The video a second ago showed one with those big waterfalls falling off of it. In the summertime, this top surface up here some of it's gonna melt, it's gonna form pools, and so it's gonna run off into the ocean and creates those big waterfalls that you just saw. So this is the ice shelf. This is the kind of an extension of the ice sheet coming out over to the ocean. What happens is you've got the ocean pounding against this. Tides are rising and falling. You've got waves crashing against it, especially during big storms. You've got a lot of wave energy hitting it, and over time, all different types of factors are going to cause these ice shelves to kind of crack, and they will break. They will crack and they will break. These are the major ice shelves around Antarctica, so there are quite a few really big ones. When they crack off and they break off, they become an iceberg. So they fall down into the ocean, they float. I'm sure you've heard before that when you see an iceberg, you're only looking at 10% of it. Okay, the 10% above and 90% below is just based on the density of an iceberg, the density of ice and seawater is what causes that to float that way. Sometimes icebergs are blue, sometimes they're white, sometimes they're green, like I said, if they flip over and you're looking at the bottom where that ice algae used to be. But whether or not they're blue or white or kind of transparent looking has everything to do with the ice bubbles inside of that are kind of trapped inside that ice. Just depending on the conditions that the ice formed under, how fast it formed, how compacted it was, it can have a lot of air bubbles or not so many air bubbles. And how many air bubbles has to do with when the sun hits it, what colors are going to be absorbed, and it appears white or clear or blue, and it just has to do with the amount of ice bubbles. Let's see, and so these will float around for a while. Sometimes they flip and turn over, and so you've got, wind and rain eroding them at the top, and down below you've got the ocean currents eroding them, and so it kind of smooths them and makes all these crazy shapes. Again, sometimes they flip upside down in storms, so they're constantly changing. Some of them will last quite a few years, other ones will drift into warmer water and they won't stick around for a very long time. All right, I'm going to play this video for you, but I'm going to kind of stop and go it, so it might skip here and there.
Have you ever heard the term tip of the iceberg?
You know that icebergs are mostly underwater, their immense bulk hidden beneath the water. But why is that so? Well, the The density of pure ice is less than that of seawater. Usually only 1/9 of the volume of an iceberg is above the water. The shape of the underwater portion is difficult to discern by looking at the above surface portion. This has led to the expression, tip of the iceberg. Here are some things you might not know about the icy islands. The life of an iceberg begins many thousands of years before it reaches the ocean. Unlike sea ice or pack ice, which form when the ocean freezes, glaciers are made of fresh water. For thousands of years, these glaciers build layer upon layer of ice, constantly compressing, moving, adding snow, compressing, and moving again as they inch along like a frozen river. It is the force of gravity that pulls them towards the sea, where a glacier may calve off to become an iceberg, or continue to spread out as an ice shelf or an ice tongue. Once an iceberg breaks away from the glacier or ice shelf, it will usually live for 3 to 6 years floating around, carried by the currents and tidal movements of the ocean. As it floats along, it is battered by waves, melts and smashes into land, and sometimes other icebergs. Some icebergs are so unstable that they have more dramatic ends, heaving up, collapsing, and sometimes even exploding. And as they fall apart, many icebergs make all sorts of strange sounds. Surface edges, the flip side is white. Although they form in far northern or southern areas, icebergs can float thousands of miles. And icebergs in the Arctic floated as far south as Bermuda. Antarctic icebergs are mostly trapped in the circumpolar current, never giving them a chance to float north. However, they have been known to interrupt shipping lanes between Australia, South America, and South Africa. For all their traveling, many people think that these slabs of ice are barren of life. But these seemingly sterile ice slabs also harbor their own complex ecosystems, and they shape the ecosystems that they pass through. They become mobile floating ecosystems. Even in the coldest seas, icebergs are always melting at least a little bit. This melting has a major impact on the ocean around an iceberg. The fresh water from the berg creates a pool of fresh water that can extend a nautical mile away from the iceberg. This water is colder than the surrounding seawater, and the temperature variation creates thermal currents in the vicinity of the iceberg. Life thrives on and around an iceberg. Young ice fish hide in small ice holes to avoid predators, while a variety of invertebrates, like jellyfish and siphonophores, congregate in the area. Many of them come to feed on krill, tiny shrimp-like creatures. Snow petrels nest on the icebergs and feed on the sea life nearby. Whales and seals and penguins seem to like them too. And even now that you know all this, we're still at the tip of the iceberg. There are
Okay, the last type of ice here is sea ice. So this is what I've been talking about in the Arctic Ocean. This is what covers the Arctic Ocean. And this is a picture of it kind of broken up. This might be towards the end of winter. It's starting to break up. So along the coastlines, you might see something that looks like this, but out in the middle of the Arctic Ocean, if you're standing on sea ice, it's going to look like you're just standing on, a mountain full of snow, because there's going to be ice in every direction. It's once you get closer to the continents that you're going to see this broken up stuff like this. It's also called pack ice. Sometimes it looks like this, kind of like big kind of slates of ice floating. Other times it looks kind of like these pancakes. Again, sometimes it's just ice as far as you can see, and you can't tell that you're standing on an ocean. Sometimes where you've got ocean currents that kind of are kind of pushing it, and they kind of pile it up together. And so you get these piled up pieces of ice, and it looks kind of like floating rocks of ice, basically. And so it can look, it has a lot of different appearances to it. It's called pack ice a lot of times instead of sea ice. One important thing to say about this is that it reflects a lot of sunlight. And so if you look right here, okay, so imagine this as an ocean covered with a thick layer of sea ice. The sea ice is going to reflect back a lot of the sun energy back into the atmosphere. And so 90% of the heat energy is reflected back into the atmosphere and doesn't enter the ocean. Only 10% of the heat energy coming in from the sun is actually going to be absorbed from the ocean in this location. And then let's get me out of the way here. If you look at now at an ocean here that have any sea ice, 94% of that heat energy is going to be absorbed by the ocean, and only 6% reflected back out. And so when we talk about a little bit about climate change in the coming weeks, this becomes very important because when you lose the sea ice, you're losing the ability of the ocean to reflect back out that heat. And so the loss of sea ice is happening because you have a warmer ocean, but now that sea ice being gone is allowing the ocean to become even more warmer because it's absorbing so much more sunlight because the ice itself is missing. And so that's a big problem, and so we'll come back to that. Okay, so again, just the extent of the sea ice, it covers from Canada here all the way over to Russia and everything in between, and so continent to continent, and so that's what winter looks like in the Arctic Ocean. And then this is kind of a cool satellite video. So this is Antarctica, obviously, and this is the sea ice in the winter extended off the continent there. So very interesting. All right, so we never really got into polar bears. We did all the mammals except for polar bears, so I'm going to talk just real quick about them, give you a few facts that you may not have known about polar bears. Okay, they are the largest bear. They're bigger than grizzly bears. They're bigger than panda bears, anything else like that. So they're the largest bear on the planet. Their feet are more webbed than other bears. Obviously, they are very good swimmers. They have been found by ships swimming way out in the middle of the Arctic Ocean. I don't know if they do that on purpose or if they get lost or what, but they can survive. They can swim for a long time. They don't hunt swimming in the water. They do not jump in the water and chase after seals or whales. They hunt, out of the water, but they are very good swimmers. They can swim very long distances. Their fur is designed to repel water, not to the same extent as the sea otters that we talked about, but they do have this very thick fur that keeps them warm, keeps water out to some extent. Only found in the Arctic. Okay, no polar bears in the Antarctic, only in the Arctic. Their fur, let's see, picture here. The fur of a polar bear is actually not white, it's translucent, it's transparent. So they actually have clear fur, and it's actually hollow, almost like a straw, like a clear straw in a way. So when the sunlight hits it, it appears white because there's so much of it, but it's actually clear if you were to look at it like under a microscope. And that is, it's so that their body can take in the sun. It just has to do with the way the sun reaches their skin. So they have clear fur, and they actually have black skin. And so if you were to shave a polar bear, their skin would be black underneath. It is not, I don't know what you would expect it to be, white or tan. It's not something light colored since their fur is so light colored, but they are actually black underneath. All of the green is where you find polar bears, and so here's that Arctic Circle again. Okay, so a lot of polar bears are living where you see that midnight sun and polar nights occurring. But the green, this is where you find them, and so let's talk here for a minute about their movements. So polar bears are hunting for mostly seals, but also to some extent whales. And so they're doing this on the ice, like this guy here. Okay, they need to be out on the ice in order to do this. In the winter, that ice is going to extend from over the entire Arctic Ocean, all the way towards the continents. Okay, and so this is when they're able to walk out onto that ice and hunt for those seals and hunt for those whales. Okay, those are when those animals are going to be trapped by their breathing holes. And so they spend the entire summer eating as many seals as they can, and whales if they can catch them. And they are trying to eat as much blubber. They have to eat animals that have blubber. They don't want to hunt some Arctic fox or some kind of bird because they don't have the blubber, they don't have the fat content. And so these polar bears are going to feed on as much fat as they can from other marine mammals throughout the winter, or throughout the winter. Eat as much of it as they can. Okay? As soon as this ice here starts to melt and go away, they can't hunt anymore. And so in the summer, as it starts becoming summer, polar bears retreat inland. Okay, so they're going to go back into those very northern parts of Canada and Alaska and Russia. And during the summer, they don't hunt, they don't eat at all. Okay, so they have to eat enough each winter to get themselves through the summer. So they have to eat enough fat to get themselves through the summer. And if they're a mother polar bear, they've got to also make sure that their cubs eat enough fat to get themselves through the summer. Okay, during the summer, they're kind of sociable. They don't ever hunt together. But in the summertime, they retreat inland. All of a sudden, they're friendly with one another. And they become a completely different personality. And they just kind of hang out. They don't do a whole lot until winter approaches again. And then once that ice starts freezing over closer to the continents, they can start making their way out. Okay. They don't hibernate. Everybody thinks bears hibernate. And although a lot of different types of bears do, they don't all. Now, a female polar bear that's pregnant will build a snow den for herself, and she will give birth in that snow den and then emerge in the spring with her cubs. But but male polar bears will never hibernate, and unless they're pregnant, the females won't either. Okay. All right, so we're going to end here with a little bit of an introduction to climate change, and we'll talk a lot more about this next week. But the problem for polar bears is that not only is this ice, in the summertime, what's happening is we're seeing less and less sea ice, okay? So ice comes and goes, winter to summer comes and goes, comes and goes. But what's happening each summer, over the past few decades, we're seeing less and less ice returning in the wintertime, or sorry, less and less ice left when it melts off during the summertime. And so, and also the time period that the ice is around is changing. And so as our planet is warming, as our oceans are warming, say for example, you're a polar bear and you have exactly 5 months to catch all of the seals and the whales that you need to catch for the year to make it through the summer. Okay, we'll say it's a little bit warmer of a year, and that ice, it takes a little bit longer for it to form. Okay, so say it's October, November, and that ice is starting to form, but it's a little bit slower. It takes 2 weeks later than it normally does. Okay, and so you just cut off 2 weeks off of that polar bear's hunting time. Okay, and then they go out and they hunt for the winter, but then it's a little bit warm of a spring, and so instead of the ice melting, maybe mid-March, maybe it melts off early March, okay? And so you've taken another 2 weeks. And so now in 1 year, you've taken off 2 weeks and 2 weeks and almost a month of the hunting time for the polar bear. And so that affects them drastically. They have a very difficult job as it is to eat enough blubber throughout the wintertime. And so when you start taking away, days or weeks off of their hunting time period, it really harms them. The other problem is a lot of the sea ice is thinner. And so again, we'll get into some of that next week. And so that's just kind of a little bit of an introduction and a tie-in to what we're going to talk about next week. Okay? I think that's it. Oh, we're going to skip that video because we've taken way too long already. Okay, so that's it. The first thing that you want to do now is make sure you let this video play all the way through so that Edpuzzle will tell me that you finished it. And then you want to get started on the assignment. So if you look under the classwork tab where you found this in Google Classroom, you will find the assignment. It's actually a pretty short one for this week. I will give you one assignment every week, and in the future it probably will be longer. I gave you kind of an easy one. It was the first week, so we're all kind of getting used to all of this. Once you finish the assignment, you want to turn it in by Friday, and you want to take the quiz. Okay, so this Edpuzzle, the one assignment, and the quiz, and then you are done for the week, and turn it all in by Friday on midnight, and then by either sometime throughout next weekend or by Monday morning, you will have a post for next week's assignment. It'll be a whole new topic. All right, bye guys.